There is a ship on the ocean right now that can sail to any coastline on Earth and plug an entire city into clean power within hours of arriving. Not in 10 years, not in a prototype facility. Right now, already built, already tested. China made it. And that is not even close to the most impressive thing China has put on the water. Over the next few minutes, you are going to see machines that reach the deepest point on Earth, build record-breaking bridges in open ocean, and move enough cargo in a single trip to stock an entire country's shelves. Some of these ships have no real comparison on land. They are changing the rules of global trade, deep ocean exploration, and how the world makes power. And most people have no idea any of them exist. Here are 10 of the most extraordinary Chinese ships operating right now. And the one at number 1 will change how you think about what humans can actually build. But to understand how China reached this level, you have to start with the ship that proved they could stand completely on their own, in the coldest and most dangerous places on Earth. Number 10. Shuilong 2, the Snow Dragon. Most icebreakers do one thing. They go forward. They push ahead, crack the ice, and keep moving. That is the entire playbook. It has not changed in decades. The Shuilong 2 does something no icebreaker had done before it. It breaks ice going forward and backward. It can spin and carve through frozen channels that would stop any normal ship dead. It crushes through 1.5 meters of solid ice thick enough to park a car on, the same way you would step through frost on a window. Here is the detail most people miss about this ship. China designed and built it from scratch using only their own technology. That had never happened before. Previous Chinese polar vessels were either bought from other countries or built using foreign designs. The Snow Dragon 2 was the first time China said, "We will do this ourselves." And they did it. Inside, 8 science labs, space for more than 90 people, the ability to stay at sea for months without needing to return for fuel. That gives China something it never had before, a permanent, independent presence in the polar regions. And the polar regions hold some of the most important untapped resources on Earth. Before this ship, China had a hard time reaching those frozen areas consistently. Now they go whenever they want, on their own terms, with their own technology. The message sent to the rest of the world was clear. China does not need to copy anyone else's plans anymore. But going from frozen surface water to the deep ocean takes a completely different kind of machine. And the next ship on this list is the one that gave China access to a resource base it previously could not reach at all. Number 9. Canuck 981. Picture a 20-story building. Now imagine that building is fully operational. People living in it, machinery running, work happening every single day, floating in the middle of the open ocean. That is basically what this is. China's first homemade ultra-deep water drilling platform can drill down more than 8 miles when you combine the depth of the water and the depth below the seafloor. That is deeper than Mount Everest is tall. All of it happening under the waves, in darkness, under pressure that would collapse ordinary equipment in seconds. It handles waves taller than 100 feet. It houses more than 200 workers comfortably for weeks at a time. And it stays perfectly still in all of it, using a heavy mooring system with giant chains anchored to the seafloor, combined with thrusters running constantly to fight wind and current, holding the massive structure in position so the drill pipe does not snap. Here is what most people will never hear about this platform. Before it existed, China had to go to American and European companies just to access deep ocean energy off its own coastline. Foreign firms controlled the technology. If they did not want to share it, China simply could not reach the resources sitting under its own waters. That is an extraordinary amount of leverage for another country to hold. The Canuck 981 ended that. China now had its own seat at the table, and built that seat entirely with its own hands. But drilling for resources is one thing. Moving them, and everything else the world produces, across the planet, is a completely different challenge, at a completely different scale. Number 8. Hongqi-Gang. This ship exists to move mountains, literally. The Hongqi-Gang is a bulk carrier stretching almost 1,200 feet, roughly the length of 4 city blocks. It carries 400,000 deadweight tons in a single voyage. One trip on this ship carries enough raw material to build 50,000 cars, or supply the steel for 15 skyscrapers, moving as one vessel across the ocean. The efficiency math behind a ship like this is what changes everything about global trade. Instead of sending 4 or 5 smaller ships that each burn their own fuel and require their own crews and their own port arrangements, one of these giants makes a single trip and gets it done. Every voyage saves millions of dollars in fuel and shipping costs. When it is fully loaded, this ship sits 75 feet below the waterline. That is so deep that only a handful of specially built ports anywhere in the world can even accept it. Automated systems monitor the cargo constantly, watching the weight distribution in real time and adjusting to keep the ship perfectly balanced so it does not lean or bend under the load. And here is where it connects to something bigger. When you can move this much material this cheaply, the entire economics of manufacturing shift. The price of building things goes down. The price of goods goes down. Everybody in the supply chain, every factory, every retailer, every consumer, feels the effect of one ship making one trip more efficiently. That is what China has quietly built dominance over. Not just the ships themselves, but the underlying economics of how the physical world moves. Number 7. Haiyang Shiyou 982. Here is something that sounds genuinely impossible. A drilling platform that keeps working perfectly, maintaining precise operations, while 50-foot waves are crashing above it during typhoon season. The Haiyang Shiyou 982 does exactly that. And the reason it can is the most counterintuitive engineering trick on this entire list. Most ships float on top of the water. They go up and down with every wave. The Haiyang Shiyou 982 does the opposite. Most of its hull sits below the surface, deep below the surface, where the power of ocean waves is dramatically weaker. Down there, a 50-foot storm surge above barely registers. The platform rides on giant pontoons, sunk deep underwater, connected to the working deck above by massive steel columns. The result is that even during some of the worst weather conditions in the South China Sea, a region famous for violent typhoons, the drilling floor stays almost perfectly still. The crew keeps working, the drill keeps turning. No stopping, no evacuating, no losing months of work to weather windows. China went from having 0 deep-water drilling capability to operating several platforms like this in under 20 years. That is not a gradual improvement. That is a complete transformation of strategic capability in less time than it takes most countries to plan a single major infrastructure project. The country that can drill in water this deep during storm season controls offshore energy on its own terms. That shift is happening right now. But what if the resources you want are not oil, but rare metals sitting in total darkness at the very bottom of the sea? That is where the next ship comes in. And this one is unlike anything else on this list. Number 6. Dayang Hao. The ocean floor is not empty. It is covered in something extraordinarily valuable. Rare earth minerals, cobalt, nickel, and manganese nodules, sitting on the seafloor like rocks scattered across a field. These are the exact materials needed to build electric vehicle batteries and smartphones. As the world accelerates toward clean energy, demand for these materials is climbing fast, and almost all of them are sitting in water so deep that reaching them was considered essentially impossible until very recently. The Dayang Hao changes that calculation. This deep-sea research ship sends robotic vehicles down to 36,000 feet, the full depth of the Mariana Trench, the deepest point on this planet. The robots run on AI systems designed to operate under pressure so intense it would flatten normal equipment in seconds. They work in total darkness. They navigate using only cameras and sonar, and they can pick up mineral nodules from the seafloor, sort them, and store them for the trip back up. The ship acts as a mother vessel, lowering submersibles into the pitch black, waiting while they work, pulling them back up hours later, with samples and data that no other country is gathering at this scale. Most people will never hear this part of the story. While other countries are still in the planning stages of deep-sea mineral research, China is actively operating at scale. The gap between sitting in a meeting room writing proposals and running submersibles at the bottom of the Mariana Trench is not a small one. It is measured in years, and China is already on the other side of it. Whoever figures out deep-sea mining first will shape the future of clean energy technology. China is not waiting to find out who that will be. Number 5. Costco Shipping Universe. The chances are genuinely high that something in your home right now passed through a ship like this. The Costco Shipping Universe is 400 meters long and carries more than 21,000 containers in a single trip. Picture a freight train 47 miles long. Now condense it into a single vessel, moving across the ocean at a steady clip. That is what this ship is doing every time it leaves port. Every single container is loaded, using computer programs that calculate the perfect weight balance before anything goes on board. Think of it as Tetris played by a supercomputer, except every piece weighs several tons, and the entire puzzle has to stay perfectly balanced on open water. If the math is off by even a small amount, the stress on a ship this large becomes a real structural problem. Costco's network reaches 160 countries across more than 320 international shipping routes. That means this ship, and the dozens like it operating continuously, are the invisible backbone of how the physical products of modern life actually travel from wherever they are made to wherever they are used. Special paint on the hull cuts friction. Tiny air bubbles released from under the vessel help it glide. The result is a machine that moves an almost incomprehensible volume of cargo at the lowest possible cost per unit, making global trade faster and cheaper for every country it touches. But moving cargo and drilling for energy are still ultimately commercial activities. The next ship on this list is something categorically different. It is a statement about military power, and it changes the geopolitical conversation about who controls the ocean. Number 4. Type 003 Fujian Aircraft Carrier. In 2012, China had 0 aircraft carriers. 0. Today it has 3, and the most advanced of them, the Fujian, launched in 2022, sits right alongside America's biggest military ships in terms of size and capability. The Fujian displaces between 80,000 and 85,000 tons. It stretches over 1,000 feet long, but the size is not the real story. The real story is the launch system. The Fujian uses an electromagnetic aircraft launch system, the same cutting-edge catapult technology that even most of the world's top navies do not have. This system lets heavier planes take off carrying more weapons and more fuel. It launches a plane every 30 seconds. Older steam catapult systems cannot come close to that speed or capability. From 0 carriers to 3, including one with technology most navies do not possess, in just over a decade. That is the speed at which China's naval program is moving. And the Fujian is not the end of that program. More are under construction right now. Number 3. Zhenhua 30. This ship built the longest sea-crossing bridge on Earth, and the way it did it is genuinely one of the most precise engineering operations ever attempted on open water. The Hong Kong-Zhuhai-Macau Bridge stretches 34 miles across open sea, the longest sea-crossing bridge ever built. To build it, engineers had to place 33 giant concrete and steel sections, each one weighing thousands of tons, with pinpoint accuracy in open water, while fighting ocean currents, shifting tides, typhoon season, ships passing through active shipping lanes, all at the same time. The Zhenhua 30 was the machine that made it possible. It stretches 679 feet, and its crane system can lift 12,000 tons simultaneously. To put that in terms you can actually feel, that is the equivalent of lifting 80 fully loaded Boeing 747 jumbo jets at the exact same moment. Here is the detail that makes this genuinely staggering. The ship does not use anchors to stay in position during a lift. It uses only its engines, a dynamic positioning system with multiple thrusters working together, fighting the ocean continuously to hold its exact spot. During critical lifts, the system held the ship to within inches of its target position for hours at a time. If the ship drifted even a few feet during a placement, the entire bridge section could be ruined. Millions of dollars and months of work gone in seconds. The company behind this ship, ZPMC, now manufactures over 70% of the world's port cranes. The Zhenhua 30 is the most dramatic example of what happens when an industrial company becomes so dominant in one category that its machines become the backbone of global infrastructure itself. Number 2. COSCO Shipping Galaxy. One trip on this ship could stock 4,000 Walmart stores or fill 80,000 shopping carts, all in a single voyage. The COSCO Shipping Galaxy is 1,312 feet long and carries 23,020 containers, making it the most advanced container ship currently operating anywhere on water. But here is the detail that separates it from just being the biggest. It is actually more fuel efficient per container than smaller ships. Not slightly more efficient, meaningfully more efficient. Because the hull was designed using computer models that cut drag down to the absolute lowest point physically achievable. The entire operation runs on a crew of just 22 people. 22. For a ship that carries the equivalent of an entire regional economy's worth of consumer goods. A central computer processes thousands of data points every second, adjusting engine speed and rudder angle to optimize fuel consumption without anyone touching a thing. The hull is coated with a specialized material that stops barnacles from attaching to it, keeping the ship fast and clean across voyages that last weeks. China did not just build a bigger container ship here. They changed the fundamental cost structure of global trade. Every country connected to COSCO's routes feels the effect of that efficiency every time a shipment arrives. The price of goods, the speed of delivery, the economics of manufacturing in one place and selling in another. All of it shifts when a ship this efficient becomes the norm. And then we reach number 1. The ship that does not move goods at all. The ship that moves power. Number 1. China's floating nuclear power plant. Everything else on this list carries things. Cargo, minerals, aircraft, steel, equipment, crew. What China built for number 1 carries something entirely different. It carries electricity, and it can deliver it anywhere on Earth. China's floating nuclear power plant program is based on Linglong's small modular reactor technology, and it represents the boldest maritime engineering project ever attempted by any country. The concept is almost absurdly simple in description. Build a nuclear reactor small enough, safe enough, and stable enough to run on a floating ship. Then sail it to wherever on Earth power is needed. Plug it in, turn it on. One vessel. 125 megawatts. Enough electricity for 150,000 homes. Going wherever the need is greatest. Think about who actually needs something like this. Remote Pacific islands that currently burn diesel fuel shipped in by boat just to keep the lights on. Offshore drilling platforms in the middle of the ocean running on expensive, polluting generators. Coastal communities in the developing world where building a traditional power grid would take decades and cost billions that simply do not exist. You sail this vessel in, connect it to the local grid, and the problem is solved within hours of arrival. When the reactor needs maintenance, you sail it out and bring another one in. The Linglong 1 was the first small modular reactor in the world to pass the International Atomic Energy Agency's full safety review process. A process so rigorous that most designs never make it through at all. Russia has a floating nuclear station called the Academic Lomonosov, but it stays permanently in one location. What China is building goes further. It moves. It goes wherever it is needed most. That is not a small step forward in the technology. It is a completely different way of thinking about what energy infrastructure can be. The entire system is engineered to shut down instantly if anything goes wrong, using cooling mechanisms that require no electricity to function. It is a floating power plant that goes to where people are instead of forcing people to build cities around where power plants happen to exist. Now step back and look at all 10 together. A ship that breaks polar ice in both directions. A platform that drills deeper than Everest is tall. A bulk carrier that moves enough steel for 15 skyscrapers in one trip. A research vessel sending robots to the bottom of the Mariana Trench. A container ship that could stock 4,000 Walmart stores. An aircraft carrier with launch technology most navies do not have. A crane ship that built the longest sea-crossing bridge on Earth. And a floating nuclear reactor that sails to wherever power is needed and plugs in. Every one of these ships points in the same direction. China is not building to keep up with where the world is. China is building for a world that has not arrived yet. And the gap between what these ships represent and what most people understand about Chinese industrial capability is growing every single day. Which of these 10 ships surprised you the most? Drop your answer in the comments. And if this changed how you see the ocean and everything moving across it, hit like and subscribe, because what China is building on the water right now is only the beginning.